So we need to show that these 3 points are collinear in nature. To begin with, let us consider a triangle with vertices A, B, and C. Now, let's say if the coordinates of vertex A is represented by x1, y1, coordinates of vertex B, let it be x2, y2, coordinates of vertex C, let it be x3, y3, then we can find out the area of the triangle by using only the coordinates. So that's given by half times the absolute value of x1 multiplied to y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. So what we'll do, we'll suppose that these 3 points, let's say point A correspond to the coordinate 1, 1. Point B corresponds to -2, 7, and point C corresponds to 3, -3. Let us suppose that these 3 points are the coordinates of the vertices of a triangle. Then what we'll do, we'll substitute this value into our given formula. So we get half multiplied to x1. So x1 is going to correspond to 1. Multiplied to is y2 minus y3. So here y2 is 7 minus y3. Y3 is -3. So we'll get positive 3 added to x2. So what's x2? x2 is -2. Multiplied to it is y3 minus y1. So y3 is -3. Minus y1, so y1 is positive 1, so we have -3 minus 1. Then we have plus x3. So x3 corresponds to 3, and multiplied to is y1 minus y2. So that's 1 minus y2, so that's 7. So we have 1 minus 7. This will be equals to half multiplied to 1 times 7 plus 3, so that's 10. Then we have -2 multiplied to -4, so that's going to be positive 8. Then we have 3 times 1 minus 7. Well, 1 minus 7 means that's -6. 3 times -6 will be -18. Now, when we sum them up, 10 plus 8 is 18. 18 minus 18, that goes to 0. So we're getting a area of 0. That means it's not actually a triangle. That means one of the point is coinciding with the line joining the other 2 points. For instance, let's say our point A, the vertex A, that is actually coinciding with the line joining point B and C, which means that the 3 points A, B, and C are collinear. So therefore, we have successfully showed that the points 1, 1, -2, 7, and the third point 3, -3, these 3 points are collinear. That means they are lying on the same line.